lesson today, they're talking about special products of binomials. When a binomial is squared. When a binomial is squared. That means what's true about the binomial then? It's being multiplied by itself. Is that what we did here? X plus 4 times itself? And x minus 5 times itself? Every single time you were taking a binomial times itself, weren't you? You were squaring it. So when a binomial is squared, the product is called a perfect square trinomial. So if I say to you, is it a perfect square trinomial? You, at some point, should be able to recognize whether it is or is not. Well, here's a shortcut that we can take. If we are taking a binomial times itself, we really can just do this. Square A meaning the what? First term. Let's write that. That makes more sense. A meaning the first term. It might not be an A. It's going to be probably an X, or in that case over there it was a 3X. Another time it was a 2X. The first term, you can square that. Then you can find the product of 2A and B. So in other words, 2 times the first term, we just said A is the first term, times B. What's B? The second term. Each binomial has two terms in it. And they just happen to be exactly the same, don't they? They both start with the same term, they both end with the same term. So to get our middle term of our answer, all we got to do is take 2 times the first term times the last term, the second term, and then our last step is to square B, and we just said B is the second term. And then notice here's another really important thing. Every single time, if we have addition in our binomial, we will have 2 additions in our trinomial answer, in our perfect square trinomial. Just like happened here. We had addition, we ended up with addition both places. We had addition, we ended up with addition both places. Okay, and then what if it's subtraction though? Well, we can still do a shortcut. We can still do the same thing. Square the first term, take 2 times A times B, but this time subtract it instead of add it, and then square B, and notice we add it, we don't subtract it. Just like happened here. Subtraction, we only had subtraction in the middle. Subtraction, we only had subtraction in the middle. Okay. So, I'll leave those for you to study some more on your own. State whether each product will result in a perfect square trinomial. So if we took x plus 5 times x plus 5, not one of ours up here, would it result in a perfect square trinomial?
Yes.
Yes. We're taking a binomial times itself. This is really x plus 5 squared, isn't it? That's really what it is, a binomial times itself, a binomial squared. Well, the next one, number 2. Would that result in a perfect square trinomial, do you think? No. What's the problem? Different signs, yeah. One's got addition in it and the other's got subtraction. That's not, oh no, that probably would not give us a perfect square trinomial. How about the last one?
Yes.
Yes. In fact, it is really 5x take away 6 squared. A binomial times itself will always result in a perfect square trinomial. Okay, well let's just do some practicing of how can we use a shortcut. Not saying you have to use the shortcut, by the way. If you want to use your foil, your rectangle, whatever, you can use it. But when you have this, why not take the shortcut? So what is A in this one in number 4?
X.
X. What is B? 7. Now, don't worry about the signs, okay? Don't worry about the addition or the subtraction. Just identify the first term and the last term, okay? We're not going to change these to add the opposite, in fact. We're going to square A. We're going to take 2 times our A times our 7, and that will give us the middle term of our trinomial. 14x. We're going to square b, which is 7, and we get 49. It was addition. So what's that tell us is going to be going on in the trinomial answer? Addition and addition. So x squared plus 14x plus 49. So when it's a binomial times itself, don't bother changing it to add the opposite, unless you're going to not use the shortcut. If you're going to use the shortcut, don't worry about it. Because this one has subtraction, so we know that in our trinomial answer, there will be a subtraction where? In front of which term? In front of the second term. Okay, what's our a value here? X. What's our b value? Just 1. Don't worry about it. Don't worry about that subtraction. It's just 1. So squaring a means we got to square x. 2 times a times b means 2 times x times 1. What do we get? 2x. Square b, that's 1. 1 squared is 1. So our trinomial answer will be x squared minus 2x plus 1. Think of it this way. To get the middle term, you're adding negatives. To get the last term, you're multiplying negatives. Okay, you try number 6 on your own then. Fill that in. And we get to see if I'm right. Am I right? Are those parentheses important around that 2x when we're squaring a?
Yes.
Yes, they are, absolutely. The 2x has to be squared. If we don't put the parentheses there, we would only look like we're squaring the x, and we would get a different answer. So very important parentheses around that 2x there. So anybody got questions about that? Okay, I'm not saying that you have to identify A every time and B every time, but if that helps you, I suggest you do. Okay, so let's do it here. A equals X. B equals 8. Remember, when we use this shortcut, we're not going to change it to add the opposite. We're just going to deal with it as it is and say, what's the first term, what's the last term? Okay? And now we're going to say, okay, I have to do my a squared, and when it's subtraction there, would this be addition here? No, it would be what? This would be subtraction here. Let me rewrite that. So a squared minus 2ab, would it be addition or subtraction here? Plus b squared, yeah. So here's a good way to do your setup until you're really good at this. Identify your A and your B, put your model down, substitute into your model, and simplify. So our perfect square trinomial should be x squared minus 16x plus 64. So there's 2 models. This is the model when there's subtraction. This is our model when there's subtraction. Let's go on, and here we have addition going on. So we're going to have a different model. But let's first identify our A and our B. What's our A? What's our A? X. What's our B? 2. Our model this time will be a squared plus 2ab plus b squared. So get familiar with those models that help us do like a shortcut. And now we will substitute our a and our b in. And we will simplify. So what's our perfect square trinomial this time? Yeah, x squared plus 4x plus 4. So can we use this shortcut all the time? Only when what? When we're squaring a binomial, when we're taking a binomial times itself. What if it's written like this? Does that make it any different? What if it's written like this instead? Does that mean we can't use the shortcut? No, we're still taking a binomial times itself, aren't we? Okay, so what's our a value this time? 7x, right? And our b value is 5. And our model is? What's our model? What happened here? I lost some stuff there. Okay, a squared, subtract 2ab plus b squared. Okay, go ahead and get that one multiplied out using our shortcut. Substituting into our model. Again, the parentheses around the 7x are showing that both 7 and x need to be multiplied. The other parentheses here are showing multiplication in the second part. So what's our trinomial answer? The first term, class? 14x squared? 49x squared. It's so easy to make that mistake and take 7 times 2. It's 7 times 7, isn't it? And then minus what? 70x. 2 times 5, can we do that order? Can we mix up the order of multiplication? 2 times 5 is 10, 10 times 7. That makes an easier multiplication. Plus what? 25. So any concerns about that? I guess I don't get to do the other activity with you that I wanted to do to help you find the patterns, but because we're going to need the time to go back here and just do this. Okay. When you multiply certain types of binomial, the middle term will be 0. In other words, when you combine the like terms, they'll cancel each other out. They will be opposites of each other. So they have an example here, just using a and b. They don't, and there, look at what happens when we take the O step, we get a times b and negative b, that's a negative ab. When we do the I step, it becomes b times a, which is ab. Those are opposites. What do opposites do? Cancel each other out because they add up to what? 0. So it's like we'd be adding a 0 in the middle of the problem. What does adding 0 do? Not a darn thing. We can just ditch it, can't we? So look at what ends up happening. This is a really fun one to do. We get a squared minus b squared. That's our shortcut. That's our model. But this works when what? What does it have to be? Look at what it says. A binomial times itself. No, not really. But they both have the same first term and the same second term, and one has addition and the other has subtraction. So as long as they have that, we call this, now these have a special product, and that's called the difference of squares. Instead of a perfect square trinomial, it's going to be the difference. It's always going to be subtraction. That's what difference means. And we're going to just square the first term and square the last term. That easy. Okay, so I'll leave those for you to study on your own, and we'll go down and do some practicing here. Okay. So first of all, let's state whether these products will form a difference of squares or a perfect square trinomial. So what do you think on number 10? Is that going to be a difference of squares or a perfect square trinomial?
Difference of squares.
Difference of squares, because one has addition, the other has subtraction. They both start with the same thing. So this one will be a difference of squares. How about y plus 6 times y plus 6? Perfect square trinomial. So we have to recognize what type we have so we know what type of model to use for the shortcut. And the last one, perfect square trinomial also. It's a binomial times itself. So the first thing you want to do is you want to be able to recognize, do I have a binomial times itself? Then I'll know I have two different models. If I don't have a binomial times itself, does it still have the same terms, but one addition and the other one subtraction? Okay, let's do this one. A plus 7 times a minus 7. That should give us the difference of squares, because they both start with the same thing, they both end with the same thing, one's got addition, the other's got subtraction. So what's our a value? A. This time it is a. What's our b value? 7. So we have a that gets squared, we have b that gets squared, and we have the difference of those two squares as our answer. I love this one. And I love to use this shortcut for sure, because I'm not going to FOIL and go through all that work if I can just do this. Now, it might be a little confusing when the binomials are not written in standard form. Don't worry about it. Leave it just like it is. So our a value is what? 2. And our b value is 3m. So we square our a, which is 4. We square our b, which is 3m in parentheses. And what is 3m times itself? 9m squared. Will you guys quit being clock watchers? It's okay. 9m squared. So what's our answer? 4 minus 9m squared. First one, the a squared minus the b squared. Don't worry about that, it's not in standard form right now, okay? So let's do it here. A equals, b equals. What's our a? X. What's our b? 8. So x squared minus 8 squared, x squared minus 64. That's easy. What's our a value? 10. B value? 2x. 10 squared minus 2x squared. You need to show me this step. You need to show me this step. 10 squared minus 2x squared. What's our answer? 100 minus 4x squared. Okay.